All right. Welcome, everybody, to Standing for Truth. My name is Donny Budinsky, and this is Sam. We are your hosts for this evening's exciting program. On Standing for Truth, we defend the truth of biblical creation. And that is exactly what we are going to be doing for the next 2 hours. We also host some awesome guests, and I am excited for our guest today. It is a real privilege to have Dr. Jason Lisle, one of our favorite creation scientists, with us to discuss this important topic. We are not only going to be defending biblical creation, but also refuting the secularist understanding of origins. In doing this, we are going to be answering challenges and engaging objections. This also includes answering your live audience questions. I am now going to hand it to Sam, my co-host, to give our guest a formal introduction.
All right. Thank you, Donny. And thank you, Dr. Lisle, for giving us your time. We really appreciate your work in your defense of the Christian faith. So Dr. Lisle is a Christian astrophysicist who researches issues pertaining to science in the Christian faith. A popular speaker and author, Dr. Lisle presents a rational defense of a literal Genesis, showing how science confirms the history recorded in the Bible. Brought up in a Christian family, at a young age, he received Christ as Lord. Since then, Lisle has always desired to serve the Lord out of love and gratitude for salvation and to spread the gospel message to all people. Dr. Lisle double majored in physics and astronomy with a minor in mathematics at Ohio Wesleyan University. He then went on to obtain a master's degree and a PhD in astrophysics at the University of Colorado Boulder. There, he used the SOHO spacecraft to analyze the surface of the sun, and he made a number of interesting discoveries, including the detection of giant cell boundaries. Since then, Lisle has worked in full-time apologetics ministry. He wrote a number of planetarium shows for the Creation Museum, including the popular Created Cosmos. Dr. Lisle has authored a number of best-selling books on the topic of creation, including Taking Back Astronomy, Stargazer's Guide to the Night Sky, The Ultimate Proof of Creation, Discerning Truth, and Understanding Genesis. So, Donny, over to you.
Sam, appreciate that formal introduction there, brother. Dr. Lisle, thank you for giving us your time. I know how busy you are, so I really appreciate the time you've given to us for today's show. Dr. Lisle, how are you doing today?
I'm very good. How are you doing?
Doing good, excited, looking forward to this. And so let's get right into it. We're excited, and so is the audience. And so what I'd like to do, since we have a lot to discuss, Dr. Lisle, and our goal here is to leave no stone unturned today. And so let's set the foundation for what we are going to be discussing throughout this important program. Dr. Lisle, what does the Bible tell us about this issue? Is the Bible obscure on the topic of origins? In other words, does it really matter what we believe about the age of the earth and the whole creation versus evolution debate controversy?
Yeah, the Bible does have something to say about origins. It begins with the origin of the universe, and that's important. God thought that important, or he wouldn't have included it. But it tells us the origin of sin. It tells us the origin of death. It tells us the origin of suffering. It tells us the origin of marriage. It tells us the origin of all these different Christian doctrines that we hold to. Those are all recorded in Genesis, and really the first 11 chapters of Genesis. That's where we see the first global judgment, where God judges the wickedness of mankind. We see an example of God's grace and mercy in that Noah was preserved. God saved him from that judgment or helped him through it in any event. And so all these Christian doctrines have their foundation in the literal history that's recorded in Genesis. And so that's why it matters. It's not that, the exact date of origins matters. God didn't give us an exact date. He gave us the time scale, and he gave us enough information that we can compute an approximate date. But the reason it matters is twofold. First of all, it is what the Bible says. And we're not to treat the Bible in a cavalier fashion and say, well, yes, the Bible says this, but that's not congenial to the way we currently understand things. And so we need to reinterpret it and interpret it to be consistent with the current traditions. Well, the Pharisees and Sadducees did that, and Jesus he would not put up with that. Secondly, the issue of death being the penalty for sin. That's really important. And almost all the compromise views out there, theistic evolution, old earth creationism, they all put death before Adam sinned, and therefore death is not the penalty for sin. It's not the enemy. And if that's the case, then why did Jesus have to die on the cross? The whole point of the gospel is that death is the penalty for sin. It was introduced when Adam rebelled against God. And so we now have a world that's full of death and suffering. It's not God's fault, it's our fault. That's rather important to the gospel. And so for those two primary reasons, I think it's important to defend the literal history recorded in Genesis, including the biblical timescale.
Amen.
Dr. Lyle.
Wilson. Go ahead,
yeah.
Sam.
Yeah, so Dr. Lyle, I'd like to ask you, there are some Christians, theistic evolutionists, that will say, well, first they'll say the cosmos looks old. And I'm wondering if you would agree, or why does it look old? And then they would go on to say, some will go on to say that the beginning of Genesis is what's called mythohistory.
So first of all, the idea that the universe must be old because it looks old is a reification fallacy. I don't mean to get too technical right off the bat, but it's an error in reasoning to say something looks old or young and then to use that as part of an argument. That's reification. Reification is where you attribute a concrete characteristic like appearance to something that's abstract, like age. Age is a concept of history. It's the time, it's the current time minus the time of origin of something. That's a number. It's abstract. You can't see age. Now, we use that term appearance of age informally with people. You say a person, well, he looks old for his age, or he looks young for his age, or something like that, or he looks like he might be this old. But we're not really, we're being non-literal when we say that, because you can't see age. What you can see are characteristics that are often associated with age in people. And so if you see a person that has no hair and lots of liver spots and wrinkles, those are physical characteristics that are often associated with great age. You don't expect to see those in a baby, for example. And so what we're looking at are called proxies, something that typically is associated with age. And you can do that if you have met a lot of people. We've all met a lot of people, and so we kind of know their age by their own profession, and we can make those kind of comparisons, and we can say, by comparing all these people, I noticed that this person has physical characteristics that are typical for this age. You can't do that with the universe. You can't say, well, let's compare our universe to all these others of different ages and see which best matches our universe. We don't have that. We have only the one. And so to say that it looks old or young, that doesn't really tell me anything about the universe. It tells me something about your presuppositions, your preconceptions about how things ought to appear. When people say the universe looks old, it looks like it's an old universe. I'm tempted to ask, how do you know what an old universe looks like? You've never seen one. Neither has anyone else. How do you know what an old Earth looks like? You've never seen one. We see the universe as it is. We don't see age. We see things that some people associate with age, but it doesn't look old or young. It just looks the way that it looks. Now, we could make some, we could say, well, based on certain scientific data, this is what we would expect an old universe would look like. Blue stars can't last billions of years. And so if the universe is billions of years old, you'd not expect to have blue stars in it. Well, yeah, but they've formed recently. Well, we've never seen that happen. Just taking the science at itself, you might say, well, there's all kinds of evidence that the universe is not billions of years old, but you can't see age. With regard to the idea that Genesis should be taken as mythohistory, really the only person I know that holds that view is William Lane Craig, and I've done a series of articles refuting his position on the website. His is kind of a hybrid position. It's kind of absurd, really, because there are people who say, no, Genesis is just myth. I've heard that before, and it's not meant to be taken literally. And that can't be defended, not rationally, because the way that Genesis is written, it's using a Hebrew form called historical narrative, frequent use of the verb consecutive, and so on. There's no doubt that the Jews intended for Genesis to be taken as history, as something that happened. It's not myth. It lacks the characteristics of myth. Myths tend to be poetic in fashion. They're not written by eyewitnesses. They're kind of poetic descriptions of an ancient past. They usually have a chaos monster that needs to be defeated. Genesis is very different from that. It doesn't have the characteristics of myth. William Lane Craig recognizes that Genesis has some markers of history that are not found in myths, like genealogies and specific ages and so on. But he can't accept that it's history because he believes in the Big Bang. He's accepted the secular view of origins and theistic evolution. And so but he wants to say, I'm a Christian too, and so I believe in the Bible. So that's why he's motivated to take it as mytho-history. He says it has elements of both. But really, mytho-history is an oxymoron, because myth, in the sense that Craig is really using it, means it didn't really happen that way. It's not literally true, whereas history means it is literally true. So mytho-history is non-historical history, which is an oxymoron. It's a category that doesn't even make sense on the face of it.
Excellent answer, Dr. Lau. This isn't the multiverse like you see in Marvel Comics and some of these other mythologies. And it's not like we have another universe that we can compare to in universe 2, universe 3, and say, oh, okay, this one looks old in comparison. And so I'm wondering, I've seen you in one of your debates with Dr. Hugh Ross. You made an excellent point. I think it was in the Q&A section in I think it was the one where Frank Turek moderated, and you pointed to Adam and Eve and how they may have looked at creation, specifically Adam. And so in relation to what you're saying about the appearing old or assuming age, would Adam, from our standards, have had a mix of what some would assume is young and others would assume is old? How would that work, Dr. Lau?
Yeah, I mean, we can make an estimate. Again, you can look at a person and say, well, these characteristics are typical of age. Height, babies don't come out big, they come out pretty small. And so if you applied those standards to Adam, you would get a strange mix of categories. You'd say, well, he doesn't have any liver spots or wrinkles or things like that, so he looks young there. On the other hand, he's maybe, I don't know how tall he was, but let's say 6'1" or something like that. He can't be super young, because it takes so many years it didn't take Adam any years at all. Adam was created as an adult. And if you assume that Adam came into existence by the same way people come into existence today, namely they're born and they grow to adulthood, you would vastly overinflate your estimate of his age. And so I think that's something we need to be careful about. If you assume the universe or Earth came about by natural processes, you will tend to overestimate your estimate of its age. And people do, for that very reason. The universe was supernaturally created by God. That's what the Bible tells us, as was Adam. And so if you'd asked Adam, how old do you think you look? I mean, he might say, well, that's an absurd question. That's a reification fallacy. But if he were to give any answer at all, he'd say, well, apparently, let's say one day after creation, you ask him, how old do you think you look? He said, well, apparently this is what a 1 day old looks like. I guess 1 day. So it wouldn't be until, many, many years later that he would learn that he and Eve were created in a very unusual way. And that's not the way that most human beings came into existence.
Right. So is it accurate to say then that and you just pointed this out, if scientists were to come an hour after Adam was created and they were to look at his height, his weight, they may be forced to conclude he's older, 30, 35. But if you were to look at his if you were to do some blood tests or DNA tests or look at his cholesterol levels, you'd be forced to conclude that he's young. And so is this similar or akin to what we find in the universe, where some people might interpret some lines of evidence as suggesting that the Earth and universe are old, but then other pieces of evidence that seem to suggest that it's young? And so there's a mix.
Yeah, and that's the case if you assume that something came about by natural means. If scientists are not assuming that Adam came about by natural means, you probably couldn't make any calculation of his age whatsoever, because God can create Adam in any state. But it makes sense for God to create Adam as an adult rather than a baby, because a baby would need someone already there to provide for them and so on. So so if you assume naturalistic assumptions and you apply them to Adam 1 hour after his creation, you would get contradictory data. You would get some results that would indicate a very young age and others that would indicate an old age, and you'd be very perplexed. And that is akin to what we find in the universe. If you assume naturalistic assumptions, you'd say, well, yeah, stars take, millions of years to form by naturalistic assumptions. If you assume they're not supernaturally created, we have stars. On the other hand, you'd see all these blue stars, and you'd say, well, they can't last hundreds of millions of years, so it can't be billions of years old. So again, you'd get contradictory results, which is exactly what we get.
What would be a good response to this? We've got a good live chat with questions, challenges, and just a lot of feedback already. And so we have a skeptic here. We appreciate our skeptics here in the live chat interacting with us. And so Andrew Cumming here is wondering, you mentioned blue stars. Dr. Lisle, and how blue stars actually are an indicator of youth. And so Andrew's asking, why are bluer stars usually found in or close to the exact places where we'd expect stars to form then?
Well, the secular astronomers expect them to form where they find them. So it would have to be that way. Wherever we would find blue stars, that's where they'd say, well, that must be a star-forming region. We tend to find blue stars in the disks of spiral galaxies. We tend to find them especially in the spiral arms. But you can find, there are blue stars in the core of the galaxy. I mean, there are some. They're not as frequent there. They're not as common. So you can find blue stars anywhere. But God has organized the universe. And so we find certain places where there are more of this and less of that and so on. The same way with other things. With globular clusters, they tend to orbit around our galaxy. They tend not to be found in the disk, whereas open clusters tend to be found in the disk. So God has organized his creation, and we find things where they're at. And so then we turn it around and say, well, we'd expect to find them in these places then, because that's where we do find them.
Right. That's good. So I'm kind of curious then, have we observed, I'm assuming the secularist or the naturalist is going to say yes, but have we truly observed a star form, or are they looking at blue stars, stars like these blue stars, and assuming, well, these are evidence of a baby star or a younger star, and so this is a star in its evolution? How does that work, Dr. Lisle?
Yeah, we've never seen a star form. We've never seen a nebula in the process of collapsing into a star. That's never been observed. The nebulae where we have been able to measure their motion, they tend to be expanding, which is what we'd expect, because normally the outward force of gas pressure is orders of magnitude greater in a nebula than the meager inward force of gravity. And by the way, I've never said that star formation is absolutely impossible. I think it's very unlikely. And so if it happens at all, it's extremely rare. But we've never seen it happen. What we do find are regions that have lots of blue stars, and so then those are declared to be star-forming regions. So if somebody has said, well, this is a starburst galaxy, or this is a star-forming region, what that means is there's a lot of blue stars there.
There is an astronomer that frequents this channel, a critic, and he suggests that if you go to his observatory, he can show star formation. So what are they doing wrong, or what's leading them to be able to say that comment and with confidence that they can defend it?
My guess is he's pointing at a collection of blue stars and saying, see, these can't last billions of years, and we know the universe is billions of years old, so they must have formed very recently. Ergo, this is a star-forming region. But I've never seen in any technical literature anybody showing me a nebula that is in the process of collapse, where they've been able to measure the motion in it, and it is collapsing into a star. It's never been seen. And it would make headline news if they found something like that, because it's something that the secular astronomers expect to find, but we don't find it.
Is there an obstacle that they wouldn't be able to overcome is based on what we know? Regarding star formation, is there like certain steps of star formation that would be difficult to explain? Something that might...
Yeah, there are. If you're asking if there are theoretical problems to star formation, there are. I'm not sure that they're completely insurmountable, but there are three things that would tend to make a star not collapse from a nebula. One is the gas pressure. Normally, the gas pressure in a nebula is much greater than the inward force of gravity. And once a star is made, see, gravity diminishes as the square of distance. And so once you have a star, it's in a very small place compared to a nebula. And so the force of gravity is able to balance the outward gas pressure. But in a nebula, where the gas pressure is enormous, that normally is not going to happen. So normally the assumption is that star formation is triggered by something like a supernova, where the star explodes, and that creates a shock wave that pushes through the gas. And if you have enough of these simultaneously or nearly so, then the idea is you could get a star to form that way. Okay, but then there are two other problems you have to deal with. One is angular momentum. Nebulae are not, they're in motion, and so they have a little bit of rotating motion. And if you squeeze that down, just like a skater when she pulls her arms in, she speeds up. That's conservation of angular momentum. That tends to prevent any further collapse, because it would require a greater inward force to compensate or to increase the centripetal force there to counterbalance that. So that's going to be a problem. And then third, you have the problem of magnetic fields. Nebulae have weak magnetic fields penetrating them. But the thing about magnetic fields is when you concentrate them, when you collapse them into a small space, the magnetic energy skyrockets. And it's like trying to push a magnet against another magnet with the same pole. It wants to repel. So magnetic field lines tend to do that. They want to spread out. And so those are the three obstacles, the three theoretical obstacles to star formation. Secular astronomers assume it happens because they have to, because they can't accept supernatural creation. But that's a philosophical basis. It's not a scientific objection.
If I could back up a little bit to your answer on the blue stars, we got some feedback from the chat, and I'm curious if I'm understanding your point correctly. So basically, we find where these blue stars are, and then a naturalist would say, well, these are where the blue stars are found, and so this is where we would expect them to find. And then we find them in similar places after the fact, and they're saying, well, it sounds circular to me. Is that right, Dr. Lau?
Yeah, I mean, there are some nebulae where we find blue stars, and maybe that's the assumption, is that, well, see, there you go, they're found in nebulae. Well, yeah, but I mean, there are some blue stars that are not found in nebulae as well. Like I said, there are some blue stars that are in the galactic bulge, and you don't really have a lot of nebulosity there. So they're found where they're found. But my point is, there's organization to the universe, and so the fact that there are, we find certain things in certain places and not others. You can make up a story that explains that, but that doesn't make the story right.
Right. Okay. Yeah. No, I appreciate that answer. Another question that came to mind, because I've seen this over and over again with old Earth creationists and theistic evolutionists, and especially those in the ancient Near Eastern camp. And so they'll point to Romans 5. And if we read it out, wherefore as by one man sin entered into the world, and death by sin, and so death passed upon all men, for that all have sinned. And so they have argued and continue to argue that the death really only applies to man and not animals. And so animals could have died and experienced death and degeneration prior to Adam and Eve's fall. What's a good response to that, Dr. Lau?
Well, if we just had that little section of Romans 5, we just had Romans 5:12, you'd say, yeah, we really can't conclude much other than it affected men. But we have the whole Bible. And Romans continues into chapter 8, which talks about all creation groaning under this bondage of corruption. And it's the same theme. It's because of what Adam did that creation groans and suffers. So it's not just Adam. We read in Genesis that God gave Adam dominion over the creatures of the earth. And so, and over the earth, in fact. And so Adam's sin affected all of creation. We know from Genesis 3 that, for example, God cursed the earth when Adam sinned. And so it began bringing forth thorns and thistles. By the way, we find thorns deep down in fossil layers that evolutionists believe to be something like 400 million years old. But we know from Scripture, no, wait a minute, that happened after Adam sinned, and as a result of Adam's sin, that specifically God cursed the earth, and thorns and thistles will it bring forth to you now. And if they'd already been there for millions of years, Adam could have said, so what? That thorns have been around for millions of years. It wouldn't make any sense. Furthermore, when Adam and Eve sinned and God confronted them, he provided skins of clothing. Where did this come from? Those would be animal skins. So we see even in Genesis that apparently there was animal death right there as a result of Adam's sin. God skinned an animal or maybe a couple of animals to provide clothing for Adam and Eve. Furthermore, the Bible says that before Adam sinned, when God looked at everything he'd made, behold, it was very good, exceedingly good in Hebrew. And so you're not going to have the enemy, death, going around and killing things. We find fossils with evidence of disease in them, things like arthritis and cancer. And if those were really there before Adam sinned, which is what the theistic evolutionists believe, that means you got a world full of death, suffering, disease, bloodshed, at least in animals. And then God's saying, oh, it's very good. I mean, it just doesn't make any sense. Jesus healed the sick. He temporarily reversed the curse. And in the future, he's going to permanently reverse the curse as a result of his obedience. That's something we all look forward to. So I would say, no, it doesn't make sense to say it was just human death. Clearly, animal death was introduced at the time of Adam's sin, and as a result of Adam's sin, because Adam was given dominion over the world, and so God cursed the earth, in addition to cursing, man in particular and woman. So man has to work by the sweat of his brow, and women now have pain in childbirth as a result of that curse.
Amen. Well said. I'd like to follow up with this because I've seen this follow-up argument now used in response to what we say on a very good creation and no death before the fall. Firstly, what came to mind in your answer was when we take the Bible in its entirety, then we have to conclude that it's not just death for man, but death for all of the biological world and degeneration in the universe in general. But I've heard, again, many theistic evolutionists say that there was death before the fall. And one of their arguments or points pertains to Genesis 1:28, where God says to subdue the earth and to also have dominion over all animals. And they'll say that in Hebrew, these words are extremely harsh and are used to indicate war, conquest, and enslavement. And so the claim basically, Dr. Lisle, is that God is telling humans to make a warlike conquest on the earth, to subdue it, and thus contradicting a perfect creation with no sin and no death. I'm curious what your thoughts are on this argument.
Yeah, I've heard that before. It's not true. The Hebrew words for subdue and rule really mean subdue and rule. The Bible really has been pretty well translated. The Hebrew word for subdue, I believe it's kavash, and it really means just to bring into order. It can be used of slaves, but I think that contradicts the old earth argument, doesn't it? Because Hebrew slaves were not allowed to be mistreated under biblical law. If you hurt your slave, he was immediately, you bust a tooth or something, you hit him so he knocks out a tooth, he's immediately freed and he doesn't have to pay back the rest of his debt. That's the way you would become a slave, or one way is you'd rack up enough debt you can't possibly pay it back. You ask a rich person to pay off your debt, and then you work for him for a number of years. But if you're mistreated, if you're treated harshly, you're immediately released. They weren't allowed to do that. But they were under the control of their master. And so that's the way that word was used. It's also used of land after it's been, you can conquer a land, but then after it's been subdued. God uses that same word of the peaceful conditions that exist long after the war is over. Hey, the land's subdued, you're all good there. And likewise, the word for rule or have dominion, I believe that's radah in Hebrew. And it's used in many other places. It's used in Psalm 72, verse 8 of the Messiah's rule. Does Jesus rule harshly? Well, if you're his enemy, he'll destroy you. Right. But does he rule over me harshly? Not at all. I'm very grateful that Christ rules over my life, and it uses the same Hebrew word, radah, maybe in a different inflection, but it's the same word. So no, those words don't have anything to do with harsh conditions or anything like that. They just mean to take control, to subdue, and to rule the same way that a king would rule over his kingdom. And a good king rules over his kingdom with grace and mercy, not with severity or harsh actions.
It's interesting you said that, because just today I'm listening to an audiobook by Paul Copan, Is God a Vindictive Bully? And I'm at the part in the book where he's going through everything that you've just stated there from a well-researched perspective. So yeah, that's great.
Good to hear.
So, well, firstly, it's a fantastic answer, and I'm just flabbergasted that argument is still repeated even today. And so I think a good approach now would be to ask you and kind of engage a little bit young biblical creation. What are some good lines of evidence to support young biblical creation, Dr. Lisle?
Well, of course, the best is we have the birth certificate of the universe. We do have the Bible, and it's not just a collection of interesting stories. It's a history book written primarily by eyewitnesses and inspired by God. And, that's not what I meant. A lot of people would say that, but why would you throw that away? Normally, when we want to talk about, what George Washington did, we consult a history book. We don't go and look at physical evidence. I mean, physical evidence might bring something to light in that. That's fine. But the history book is the best way to know what happened in the past. And we have that. We have the history book of the universe. On the scientific front, I think there's a lot of lines of evidence that would confirm what the Bible teaches. And normally the way that we discuss these is with a reductio ad absurdum. That is, we temporarily assume the assumptions of our opponents, of our critics, and then show that even under those assumptions, it leads to an inconsistency. It leads to an age estimate that is much younger than what these secularists require, because they believe that the Earth's 4.5 billion years old. They believe the universe is 13.8 billion years old. But the reason they come to those conclusions is because they're assuming naturalism. They're assuming the universe, that all things happen by natural law. God doesn't do anything. If he exists, he doesn't do anything. So naturalism, nature's all that there is, no supernatural miracles. And they assume uniformitarianism, that rates and conditions today have always been kind of the rates and conditions of the past, or any change is very gradual from those. But nonetheless, there are certain things where we can make those assumptions, even though I don't agree with those assumptions. Just to be clear, I'm not a naturalist. I don't believe in uniformitarianism. But I can make those assumptions and apply them to certain situations and come up with an age estimate that's much less than the secularists require. And so, and just about all the lines of evidence that we use to confirm a young universe are along those lines. One example that I think with Earth is really compelling is C14 decay. C14 is a variety of carbon, has 2 extra neutrons. It's produced in the upper atmosphere when cosmic rays bombard nitrogen atoms, convert them to C14. And then C14 will decay back into nitrogen with a half-life of 5,730 years. And so that's how long it takes for half of the C14 to decay back into nitrogen. And of course, plants absorb some of that carbon because it bonds molecularly to form carbon dioxide. The plants take that in, they spit out the oxygen, they use the carbon to build themselves up. And so a small fraction of plants is C14, something like 1 atom in a trillion. And then the animals eat the plants, or we eat the plants, or we eat the animals that ate the plants. And we use that carbon to build our body. And so a small fraction of human beings and animals, a small fraction is C14. And while you're alive, you're constantly eating and replacing it, even though it's decaying back into nitrogen. So the C14 to C12 ratio in you is about the same as it is in the environment. But then when you die, you're not replenishing that C14. It simply decays away. And so we can use carbon dating to tell how long ago something died. And it works pretty well when we test it on things of known age. So the assumptions there are actually pretty good. And yet, when we test it on things that evolutionists believe to be hundreds of millions of years old, like coal beds, you get thousands of years every time. See, you can't find a chunk of coal that doesn't have C14 in it. And many of these layers are buried deep down in the Earth where they're insulated from cosmic rays. So there's no real, there's no source for new C14. Some people say, well, radioactive elements can make it not in sufficient quantities. You'd need about 13,000 times more radioactive elements to do that. So the fact that we find C14 in dinosaur remains, coal, diamonds, we found it in diamonds, and pretty much anything that has carbon in it, we find C14 in it. That's an indication that the Earth is nowhere near even like 1 million years old, because if it was 1 million years old, you wouldn't have any C14 atoms left. They would have decayed away. Again, barring a source of new C14, which we don't have deep down in the Earth. So that's just one example. Decay of magnetic fields would be another. The rate at which Earth's magnetic field is decaying is consistent with thousands of years. Lots of stuff like that. I'm happy to talk about more, but those are a few examples that I like.
Well, I appreciate it, Dr. Lisle. C14 in diamonds and other material is one of my favorite lines of evidence as well. And I've heard, in terms of a rescue device or response, and I heard it in your latest debate with Dr. Hugh Ross as well. One thing they'll say, other than contamination, I feel like that's so easily debunked, that's been so overturned. But some more learned, I guess, or informed critics, they'll say, well, there's nuclear material nearby that can, where the diamonds are, let's use diamonds for example, that can recharge the C14. And so that's why we find detectable levels of C14 in diamonds that are supposedly billions of years old. What's a good response to that, Dr. Lisle?
Yeah, let me see if I can give an analogy for why that really doesn't work. And by the way, it is something that's worth investigating. The Rate research team investigated that. And they found that in order for that to work, you'd need 13,000 times, I believe that's the number, more radioactive elements than exist in nature. So it's totally unfeasible. And the reason is these other radioactive decay processes are very slow. And so you can't charge a high voltage battery using a battery that's nearly dead, okay, unless you had enough of them. Maybe an analogy would be if you had a milk carton, a gallon of milk, and you cut a big hole in the side. and the milk just gushes out that hole. That's like C14 decay. It decays quickly. These other decay methods are like take a gallon of milk and take a little pin and just put a little hole in it, and the milk will come out maybe drop by drop. Okay, that would be like these other radioactive elements that decay very slowly. And so the idea is, well, the reason we have this gallon of milk and it's gushing out the side, and it's been doing that for millions of years, is because these other gallons of milk that are dripping are refilling it. And you think, well, wait a minute, they're just, even if they're dripping into that one, that's not gonna fill it up, because it's gushing at a much greater rate than they're dripping into it. Now, you could solve that problem if you had a bunch of these slow dripping milk cartons. If you had thousands of them so that all the drops go into that bucket, you could do it. And so that's why you'd have to have thousands of times more radioactive elements than you have C14 or nitrogen by which you're recharging it in the deep layers of the earth. And we just don't have that. So you can't fill a gallon that has a big hole with a gallon that has just a little hole unless you had thousands of them, which we do not have. I hope that analogy makes sense.
Yes, it does. And I know, Sam, I know you got a follow-up question, but I know the skeptics would be thinking this, and I've heard them respond by saying, okay, fine, we get thousands of years in diamonds and coal and so on and so forth, maybe 30, 50,000 years. Well, how come we're not getting 6,000 years? How come we're not getting 6,200 years? And so how, as a young earth creationist, would we account for the dates, although contradictory to an earth that's billions of years old? Why is it still more than 6,000?
Okay, yeah, that's a good question. And the answer is, even that method, I've still made assumptions that I don't necessarily agree with. I've assumed that the C14 to C12 ratio in the atmosphere has been constant since the creation of the Earth. And that is not a correct assumption. We think that before the flood year, the amount of C14 to C12 ratio was something like 2% to 5% what it is today. And there are two independent reasons to think that. One of them is the C14 is produced by cosmic rays striking nitrogen atoms. And so that would tend to build up. At creation, there might not have been any C14 in the atmosphere. It might have been zero for all we know, but it builds up over time. And so you'd expect the C14 in the atmosphere to increase. If you don't compensate for that, you'll get an age that's about 10 times older than the true age, which is why we're getting 30,000 years instead of 3,000. And that typically when you date things that go back close to the flood year, you get ages that are about 10 times the true age, because the C14 ratio, we think before the flood, was about 2 to 5% what it is today. We'd expect that for theoretical reasons and empirically, things that are associated with the flood, when we carbon date those, we tend to get a level that's consistent with there being 2 to 5% what it is today. So part of that's working backwards, but it's at least consistent. It's what we would expect.
So does that mean the further we go back to the flood, and then also creation going back roughly 6,000 years ago, the carbon dates that we get need to be calibrated with that understanding?
Yes, exactly. And that's something that I've been looking into. I did a project a couple of years ago where I was looking into calibrating that, and I kind of put it aside. But I did find that it's consistent with there being basically no C14 at creation. The amount that you'd expect to have built up in the first 1,600 years of Earth history is consistent with there being 2 to 5%. So I found that very encouraging. I haven't worked out all the details, but yes, the closer you get back to the flood year, the more the ages tend to be inflated relative to their true age, based on other dating methods, or historic records and things like that.
Very good. Very interesting. We got a couple follow-up questions on the C14 topic, and then Sam will move into our next major topic, which I'm excited for. And so Sydney Raptor here, question for, I think it's for you. Let's see. He says, because there is no C in diamonds, C14, diamond is actually used as calibration material in testing equipment, acceleration mass spectrometers. Can Dr. Lisle confirm?
Yes, at least with, I think it was coal that they used to use, chunks of coal they used to use to calibrate certain types of detectors on the assumption that there was no C14 in the coal. They don't do that anymore. And the reason is they now know that coal has C14 in it. And likewise with diamonds, we now know that diamonds have C14 in them. With the mass spectrometry method, I don't think calibration is necessary for that method. It should detect the actual number of atoms. But there are other methods that they used to use that are, well, they still use them, but they're less precise. And those ones needed to be calibrated. They used to use coal. I don't know if they used, I kind of doubt they used diamonds because it would be expensive, but because you have to destroy the substance to carbon date it. So, but I do know that they used coal under the assumption that coal had no C14 in it. And they now know that that's false.
Wow, it's amazing. So here's another follow-up from Stephen Tibbetts. Question for Jason. Is it true that C14 formation is still faster than the amount of decay? For example, not yet reached equilibrium, and wouldn't that throw off all the dating?
Yeah, that's a good question. I think it's an open question, but I think that there is evidence that the C14 in atmosphere is still increasing slightly. It's close to equilibrium, but it's not quite in equilibrium. The rate, it does seem to be going up a little bit. And yes, that does throw off all dating. But by the way, secularists are aware that the C14 in the atmosphere has fluctuated a little bit in recent history, and they do compensate for it. They do compensate for it. We just think that they haven't compensated enough when it comes to things that are close to the flood year. So even secularists don't assume that the C14 in the atmosphere has been completely constant. They do try to calibrate it by testing it against things that have an historic date attached to it.
I think the topic of C14 in diamonds, I've not been impressed with the rescue devices presented by the anti-biblical creationists. I think it really is just an extremely powerful line of evidence for young earth creation. But the first book, one of the first books I ever read as a new young earth creationist 7-8 years ago was your book, The Ultimate Proof for Creation. I was really blessed by it. Correct me if I'm wrong, but isn't it true that because it really is a battle of worldviews, no matter how strong the evidence is, either side could have a rescue device because they're just trying to account for the data in light of their presuppositions and their worldview? So should we be surprised? Because sometimes I am kind of caught off. I'm like, this is such amazing evidence for young biblical creation, but yet they're not tapping out. We've engaged their counters and their rescue devices in a sophisticated manner, and they're still not tapping out. Yeah. And so is this because it really comes down to a worldview and an assumption issue, Dr. Lisle?
It really is. And that's part of what motivated me to write that book, is because I see all this evidence for creation. And why are people not convinced by this? Because it's so, especially with C14, that is devastating to the millions of years view. I can't think of a good rescuing device for that. I mean, I'm a physicist and I'm pretty creative. I can't think of a good rescuing device for that. But that doesn't mean somebody else can't. Or you know, if you're a really creative person, I mean, I'm sure there are ways to do it. I'm sure there are ways to do it. And that's always the case. Mm-hmm. And I'm not just referring to my critics. I mean, there are things that secularists can present. They say, look, here's evidence for my position. And maybe I don't know what the answer is right away. I can come up with rescuing devices too. We all do this because we all have a way of thinking about things. We have a belief system that we take to the evidence. No one's completely neutral. We'd like to think we are, but we all have beliefs about how to interpret the evidence. And so that was really what The Ultimate Proof of Creation, the book, was all about, is about how do we get to the bottom of this when we have our different worldviews, our different presuppositions, and we each interpret the evidence according to our own presuppositions. How do we get anywhere? And so that book was basically showing that only biblical presuppositions would make things like knowledge, science possible.
What if a critic said, well, okay, we all have our rescue devices, but it comes down to who has the most parsimonious explanation, or maybe the best rescue devices? Because I'm assuming some rescue devices can be a lot weaker than others, where one rescue device, you're like, okay, I can kind of see how that might work. What would be a good way to engage that, Dr. Lisle?
Well, yeah, I like simplicity, but see, I would argue even that's a biblical principle, because God, the way He's organized the universe is kind of a fractal pattern where you can understand the basics, and then there's details, and then you can try to understand those, and so on. There's a simplicity that's in Christ according to Scripture. So truth has a simplicity to it. So even things like Occam's razor, I would argue, are predicated on the biblical worldview. So I tend to agree with Occam, with Occam's razor when it's used properly. But even there, what you perceive to be the simplest position will be influenced by your worldview. Because I think that biblical creation by far is the simplest, most straightforward interpretation of the evidence. But my secular colleagues might disagree because they're looking at it through their secular lens. I get that. So that's why it has to come down to whose worldview can make things like science and logic sensible, right. make it justifiable to where it makes sense for us to assume that logic and science are good procedures by which we can test certain truth claims. And I would argue it's the biblical worldview that does that. But yes, I'm a fan of Occam's razor because I think it comes from a biblical worldview.
Amen. Amen. Well, we're slowly moving into the topic of the Big Bang, which I'm excited for. But let's leave no stone unturned here, as we just had a skeptic of biblical creation put forth what he thinks is a good rescue device. So we'll interact with it. Mr. Anderson, appreciate your comment here. And so he says a good rescue device for C14 ? The simple one is that you are talking about the trace amount of C14 in the instrument. What are your thoughts on that, Dr.
Yeah, they can pretty well eliminate that because they can put in a blank sample, and they've done that, and you get nothing. Depending on, there's different ways of doing this method, and some of them have a background radiation, but I think the mass spectroscopy method, you put in a blank sample, you'll get nothing. So that tells you there's no C14 in the instruments. I mean, that was a good idea, but they can pretty well test that.
Yeah, and that's why I kind of moved to the nuclear material argument that I find more...
That's the most common rescuing device. Yeah.
Right. And the contamination one, background radiation, I mean, those have just been demolished. And then, like you said, with the nuclear material nearby that could recharge, the RATE team addressed that. They studied that, they analyzed that, and found out you need, if I remember correctly, you said about 13,000 times more nuclear material. So, okay, very, very good, Dr. Lisle. I appreciate that. Sam, over to you, brother.
Yeah, thank you. So the James Webb Space Telescope went up, and the Big Bangers, they made some predictions, the gold standard of science being testable predictions, and you made some predictions also. So can you tell us about how those predictions, their predictions, came out, and yours also?
Yeah, it's a very exciting time to be a biblical creationist because we now have access to galaxies that are farther away than anybody could have detected just a few years ago. And so in January 2022, before the James Webb had taken any data, I'm not even sure it had reached the L2 Lagrangian point yet. But in any case, I made some predictions about what I was expecting it to detect based on my understanding of biblical creation. And one of the things I predicted is that the James Webb Space Telescope will find galaxies that are at much greater distances than the Big Bang advocates were expecting. The reason for that, you see, in the Big Bang view, as you look out into space, it's kind of like you're looking back in time because allegedly the light took a long time to get here. So you're seeing things not as they are, but as they were. It turns out that depends on how you define now. It depends on what's called a synchrony convention, which we can get into or not. It's complicated. But in any case, they were expecting that at a certain distance, you're looking back to a time where galaxies didn't exist yet. And based on various models of the Big Bang and galaxy evolution, they were expecting that to be at a redshift of about 14. That should be where the earliest galaxies. Redshift is, it correlates to how far away something is. So a redshift of 14 is incredibly distant, and they were not expecting to find galaxies much further than that. I predicted that they would, that the galaxies would continue beyond redshift 14 further out into space. And I predicted that these galaxies would be comparable to nearby galaxies in the sense that they're fully formed, mature galaxies. The Big Bang advocates were expecting that as you look far out into space and therefore back in time, in their view, you're seeing galaxies as they were when they first came into existence. They ought to be babies, so they ought to be very low mass galaxies, clumpy, irregular, because it takes time for the stars to smooth out and form these nice spiral structures. So basically the opposite of what I predicted. And then finally, I predicted that these galaxies would have what we call metals in them. And in astronomy, a metal is anything heavier than helium. So everything on the periodic table except the first two is a metal. And in the secular view, the only metals that should exist in the earliest and farthest galaxies should be would be lithium. So they were expecting none of the heavy stuff, nothing like oxygen and carbon and stuff like that, these heavier elements, because the Big Bang can't produce those, even in their view. Those are supposed to be produced later by stars, the heaviest class of stars. And then when those stars explode, they release the heavier elements into the universe, which are then gobbled up by the next generation of stars. And so the generation 2 stars have some metals. Generation 1, which we would call population 3, would have no metals. So the earliest galaxies shouldn't have any. So those were my 3 predictions, and they're basically the opposite of the secular predictions. Secularists saying galaxies stop at around redshift 14, and you really can't find them beyond that because that corresponds to a time where they haven't had time to form yet, according to the simulations, according to the theory. I'm saying no, they'll continue to go out as far as James Webb can detect. Second, the Big Bang advocates were saying the very farthest galaxies ought to be babies. They ought to be low mass, clumpy, irregular galaxies. I'm saying no, they'll be mature galaxies. With structure, maybe I don't think I specifically said spiral structure, but that's what I was implying. And then third, they were saying the farthest galaxy we should finally find these population 3 stars, 0 metallicity. And I'm saying no, these farthest galaxies will have heavy elements in them, metals like nearby galaxies. And in July of 2022, James Webb sent us back the first data from these distant galaxies. And we found, lo and behold, galaxies at redshifts way beyond redshift 14, 16, 18. There's some estimates go out to a redshift of 20, which is way farther than the secularists were expecting, but I was expecting that. They found that these galaxies are far more massive than they were expecting. They did not find the baby clumpy galaxies. They found evidence of fully formed mature galaxies, even galaxies with spiral structure. They've now found evidence of barred spirals, which are not supposed to form for like 6 billion years, but there they are. So I was right about that one too. And the James Webb spectroscopy revealed that there are indeed heavy elements, things like oxygen, in these most distant galaxies. So in all cases, the creation predictions were right. The Big Bang predictions were wrong.
So Dr. Lisle, you also made some predictions about how the critics would respond.
Yeah.
Could you tell us a bit about that?
Yeah, and again, I know about rescuing devices, and so I figured I was confident enough in my predictions that they would be right that I even decided to speculate on how secularists would respond, and I predicted that they would basically, rather than give up the Big Bang, because they're going to hold on to that tight, the alternative special creation, they don't want to believe that. So rather than saying the Big Bang's wrong, they'll just push galaxy formation back to an earlier time. And they'll say, wow, galaxies must have formed much earlier than we had previously predicted. And that is almost verbatim exactly how they responded. And I don't have the quotes in front of me, but I consulted a number of different articles, some technical papers even, that said, yep, galaxies formed much earlier because they're finding these galaxies at distances they weren't expecting, which in their view corresponds to a much, much earlier time. And so we were right about that too. And I think that's neat because the Bible not only tells me something about the universe, which allowed me to make these predictions, but it also tells me something about human nature, which allowed me to make the predictions about how human beings would respond. And so I think that's pretty neat. The Bible really is the best place to start.
So,
Amen.
So with this alteration of their timeline, would that affect the timeline by which they suggest that our current galaxy formed?
Oh, that's a good question. Probably not, because they think our galaxy is something like 10 billion years old. And if you want to add, if you want to push it back another few hundred years, I don't think a few 100 million years, I don't think that's going to affect our galaxy too much. But it does affect it shows that the simulations were wrong, because the simulations showed that these galaxies take longer to form than that and would take much longer to become spirals. So it challenges galaxy formation models very severely.
What do you think this information should have meant for the people who believed in the Big Bang?
I would hope that it would give them pause, that they would step back and say, wait a minute, is our underlying worldview possibly wrong? I mean, we've got a creationist. We've been saying that science is all about making good predictions, and it is. The creationists are making the right predictions. Our predictions were wrong. Maybe we need to rethink things here a little bit. Maybe we ought to consider biblical creation. And don't get me wrong, I'm not suggesting that they should believe in the Bible because of this new evidence. They should believe in the Bible because it's God's word. Right. But I would hope that people who have not been believing the Bible because it's God's word would consider starting. I think that this evidence is very compelling. It's consistent with creation, and it does challenge the standard paradigm. And the other thing that's interesting too, I have seen some secularists publish in secular peer-reviewed literature, technical literature, some models that are contrary to the Big Bang. They're not creation models, but based on these new lines of evidence, they're challenged. That the tired light model is coming back a little bit. I don't think that'll catch on, but I think it's interesting. That was a model that was abandoned almost a century ago, and now it's back because the data do not match the predictions of the Big Bang. So I think that's exciting. So at the very least, I hope it'll get people to question, maybe we need to reconsider our underlying paradigm rather than simply slapping band-aids on this model, coming up with rescuing devices to explain away the data.
Right.
If I can ask one more type of follow-up. So the Big Bang model, it has changed throughout time. You know, when I was young, it was explained much differently. So it's currently explained as if you were to take a partially blown up balloon, put dots on it, and blow the balloon up. They'll suggest that, you know, almost like it has like a sphere that's expanding. Is that part more philosophical than it is scientific? Or do you think that they actually have scientific justification for suggesting that the shape of it is more of a sphere, which would mean, it seems like that would mean that there would be many more dimensions, because you would have an internal dimensions in there, at least 3, and then an external dimensions, which would be 3 more. So you're at least 9 dimensions. And if there's a barrier outside, what does all of that mean?
Okay, that's tricky.
Okay.
So the idea that the fabric of space expands like a balloon, I would call that a scientific hypothesis because it's testable. And in fact, it's been challenged recently by me. I published a new model that challenges that idea, because I always accepted that. Not that I believed in the Big Bang, but I thought the fabric of space expands and it carries the galaxies along with it. Does that imply extra dimensions? Not necessarily. Not necessarily. And the reason why we tend to think in terms of Euclidean geometry, where the internal angles of a triangle add up to 180 degrees, and it's nice. And that's the geometry that we learned in high school. It's not the only geometry that's out there. But it turns out there are other geometries that allow for an expansion of the universe that don't require any dimensions outside of it. I know that's a little hard to grasp, because when we think, well, if you think of the surface of a balloon as a basically 2-dimensional structure that's expanding in a 3-dimensional space, that's a mental way of picturing the expansion. It may or may not be accurate, but you'd say, well, doesn't that require a larger dimension? Not necessarily. You could have a balloon that's 2-dimensional that expands only in 2 dimensions, but does not obey Euclidean geometry. I don't know if that makes sense or not. The embedding is where we pretend there's an extra dimension, and that keeps the geometry Euclidean. But you don't actually have to do it that way. Mathematically, it's not required. So we don't need extra dimensions. That doesn't deny that there could be extra dimensions. It's just we don't need them to account for the expansion. The idea that the fabric of space expands like a balloon is allowed by Einstein's general relativity. It's not required, but it's allowed. And under certain assumptions, you would expect that to happen. And so that was realized in the 1920s. There were 4 scientists that independently realized that Einstein's solutions allow for the fabric of space to be expanding or contracting. And then when Edwin Hubble discovered and published in 1929 his Hubble, what we now call the Hubble law, that galaxies are all apparently moving away from us and from each other, some exceptions that are really nearby. But there's a general trend that the universe seems to be getting bigger. People thought, aha, that means the fabric of space is expanding and the galaxies are just going along for the ride. But it turns out that makes certain testable predictions about the relationship of a galaxy's apparent size, how big it looks, and its actual distance away from us, which we calculate by its redshift. And it turns out that if the fabric of space is expanding, there's actually a magnification effect that kicks in. You know how things, when they're farther away, they look smaller. That's perspective. Their angular size shrinks. Now, in an expanding universe, that effect is there, but beyond a certain distance, there's another effect that overcompensates for it and makes them look bigger again. And so if the fabric of space is expanding, galaxies beyond a redshift of 1.6, rather than looking smaller as they get further away, they should start to look bigger again, due to this magnification effect. I won't go into the math of why that happens. It just happens. And secular and creation physicists, we would agree that happens if the universe is expanding. But what I realized when I looked at these James Webb galaxies, I mean, we're looking at tremendous, they ought to look huge. They ought to be much bigger than they are. And the secular assumption is, well, they're really tiny for some reason. But we already know they're massive. Their mass is similar to nearby galaxies. And so what I did was I computed what would their apparent size be if the fabric of space is not expanding, but in fact, galaxies are just moving through space. And it turns out it matches almost exactly the sizes of these galaxies as we're seeing them. And so I'm calling this the Doppler model. It absolutely is devastating to the Big Bang, because you can't have a Big Bang unless the fabric of space goes back to a point at one point. And that apparently is not happening. The fabric of space is more or less stationary, and galaxies are just moving through it, such that the farther away they are, the faster they're moving. And so, but their redshifts are caused by a simple Doppler effect. And so apparently the correct picture is not dots on an expanding balloon, but pool balls on a pool table after you crack the deck. The ones that are moving away the farthest are the fastest, but the table's not expanding. So that's called the Doppler model, and I've recently published an article on that in the Answers Research Journal. So I hope that wasn't too technical, but hopefully.
No, that was good. And I think your last illustration there made a lot of sense of it. And so firstly, I've posted your recent technical paper in the Answers Research Journal in the chat for people to read. And so essentially it comes down to the picture that we see may be better explained by this Doppler shift rather than expanding space, which has been the prevalent view for years and years.
Yep, both of them pardon me. Both of them produce a Hubble law, but only.
No worries, brother. You're doing great. And this is some technical stuff as well, and you're explaining it in a great way.
Both models produce a Hubble law, a redshift, but only the expansion produces this magnification effect, so which we do not see.
So I've heard some critics to your paper, they've said, oh, well, his first mistake was assuming that the universe is not expanding. But isn't that the point of you investigating this, is you're going to assume that it's not expanding and let's see if it works. Let's see if the data fits. Or am I misunderstanding that? Yeah,
you got it right. I didn't assume it one way or the other. I'm saying let's test it. Let's see what the size of galaxies should be if it's expanding, and then they grow after 1.6. And then let's see if space is not expanding, but galaxies are just moving through it, then they continue to get smaller at a redshift of 1.6 and forever after. And then I plotted the actual measured sizes of these galaxies, their angular sizes, and they match perfectly what you would expect if space is not expanding. So this isn't something that I was necessarily expecting to see. I bought the expansion of space, as did almost everybody else early on. I just didn't think it started from zero. I didn't think it started from a Big Bang, but I thought space was expanding. And the data are not consistent with that. The data are consistent with a universe that's not, a space that's not expanding, but the galaxies are moving away from each other. So the universe is still expanding. It's just that space, the fabric of space, doesn't expand.
Right. So is it almost becoming the cool thing again to question the Big Bang and to propose these alternative ideas?
A little bit. A little bit. And the fact that I've seen some articles in the secular peer-reviewed literature that challenge the Big Bang, you couldn't have got away with that a few years ago, or it was very rare. But I'm seeing that. I'm seeing it in the AstroPH online journal. I've seen several articles that have questioned the Big Bang as a result of this new data, I've seen a hybrid model where they try to combine tired light with expansion of the universe, and that doubles the age of the universe. That gives a little more time for galaxies to evolve and so on. But I thought that's interesting.
It brings to mind some of these theistic evolutionists who rely too much on an apologetic against atheism that relies on the Big Bang. They've written tons of books on it. They've based a lot of their debate openings on it. So if the Big Bang's overturned, what does that do with the Christian apologetic that focuses on the Big Bang to argue for the Christian worldview?
That's why you don't base your apologetic on a particular idea of science, especially one that's incompatible with the Bible that you're trying to defend. because when that thing is refuted, and if it's contrary to the Bible, it will be refuted, then you're left out to dry. All the people that were convinced by your arguments, they're like, wait a minute, right? I mean, if you can convince somebody by the evidence, you can convince them of the opposite by the evidence. You got to be real careful about that. That's why I'm a presuppositionalist. That's why my basis for believing in the Bible is that it makes knowledge possible, which is what the Bible itself says, and not on any particular line of evidence, but the fact that the Bible makes science possible. That's the way to go. I would say all those people who were trying to use the Big Bang as an apologetic argument, they have egg on their face now, because the Big Bang has been very solidly challenged by these new data.
It's fascinating. So before I get to the question, I like to say in the podcast, it's a great time to be a biblical creationist. And it has always been, but now it's really a great time to be a biblical creationist. So this comes in from Andrew Cumming, and he's interacting with your points here in the Doppler model. So he's asking, how does Lisle's Doppler model account for the cosmic event horizon then at high redshift?
Yeah, it does account for it. It would basically I'm assuming that the Doppler, the Hubble law remains linear at all redshifts, and so far it seems to. And then the upper limit then would be the speed of light, the round trip speed of light, c. And so that does create a sort of horizon. There in the Doppler model, there's a farthest galaxy, or perhaps more than one farthest galaxy. There's a limit in terms of distance, not in terms of redshift. The redshift can go up to infinity, but the distance, there's a maximum distance at which we should find galaxies. I didn't talk about that too much in the paper. It's there, but I do want to follow up with this. I kind of want to see if this model catches on, and then I want to explore the implications of it. But one of the implications is that there's a maximum distance at which we can see things, but not a maximum redshift, as strange as that seems. But there is a relationship between redshift and distance, and so that creates a cosmic horizon. Even though the number of galaxies, because they're the farther away they are, the faster they're moving, close to the speed of light, and therefore they get length contracted, and you can fit more galaxies in there. So theoretically, the number of galaxies in the universe could still be infinite, despite the fact the volume of space in the Doppler model is finite.
Wow. So, and correct me if I'm wrong, your paper, I watched a recent lecture talk that you gave on some of the material in your paper, and you pointed out that at least, I think it was 3 PhD Christian astronomers reviewed it, and you got a lot of good feedback. And in terms of secular publication, I understand you can only publish in one place, but it probably would have been solid enough even for a secular publication. Is that right, Dr. Lisle?
Yeah, it is. I'm actually very, very confident that it would have passed secular peer review and would have been published in the secular literature. Some people have questioned, why didn't you do that? Because I want to publish it in creation literature. I want the secularists to see that creationists are doing good science. And if they want to learn about the universe, they need to go to the Answers Research Journal to see the latest scientific research. There's nothing wrong with publishing in secular literature. I probably would have removed a couple of the specific creation lines, but I'm fairly confident that it would have passed, because there have been similar articles that have been pushing the tired light hypothesis that have passed and have been published in the secular literature. And they also question expansion of space. It's just they think that instead of a Doppler effect, that light simply loses energy as it travels by whatever mechanism. I don't think it doesn't fit the data quite as well as my model, but the fact that it got published in a secular journal, and I've got the reference to at least a couple of those in my technical papers, so you can see that apparently it's cool to challenge the Big Bang again.
Yeah. That's awesome. You're doing a great job doing it too. So here's a follow-up here. We got a lot of interaction in the chat. So we're only going to be able to get to select a few of these, the most pertinent ones I think we'll do. So here we go. Maximiano Xavier, Dr. Lisle. If the redshift is due to a relativistic Doppler effect, what we've been talking about here, why would the speed of recession follow the Hubble law? Galaxies could have the same speed in different distances.
Yeah, so it goes back to the way that God started the universe. Apparently, God gave galaxies a higher velocity the farther away they are from us, probably as a design feature, as a stability feature. If God made all the galaxies stationary in a finite volume, eventually gravity would cause them to collapse in on themselves. Even if space isn't expanding or contracting, you could expect the masses would collapse in. So by giving them an outward velocity, it prevents that collapse. It makes the universe stable. So that's, I mean, I don't know. You're kind of asking, why did God do it that way? I don't know, but one possibility is for stability. And of course, galaxies do have, in addition to this Hubble flow, galaxies do have a little bit of velocity in and of themselves, which we call peculiar velocities. And so that's why you can have nearby galaxies can even be blue shifted, like M31, the Andromeda Galaxy. But statistically, they tend to be moving away from us and from each other. It would have to be the case if they're radially moving away from us, they would be moving away from each other as well at a rate that is proportional to their distance, probably for the purposes of stability.
Very good. I appreciate that. And also the interaction from the chat. And so I'm very curious because your predictions here, I'm going to backtrack a little bit because you hear evolutionists all the time say that the gold standard of science is making testable and falsifiable predictions. And then you test those predictions, see if they come true or not. And so you made predictions that are future. They're not retrodictions, but they're future testable predictions that have been confirmed by the James Webb Space Telescope data. Mm-hmm. And so is this not an example of creationists making testable predictions that end up being confirmed because so many critics of biblical creation argue that we can't do that?
Yeah, I mean, that's exactly what happened. And it's all documented. You can go back and read the 2022 January article, which was written before James Webb had taken any data. You can confirm with Internet Archive that, that's the date. I mean, there's no doubt about that. And then you can confirm and see that James Webb did, in fact, find that. Likewise with the Doppler model. The Doppler model makes predictions that have yet to be verified, that will take future James Webb Space Telescope observations. For example, and the neat thing about the Doppler model is it makes very specific quantitative predictions. I'm expecting not only to find galaxies at increasing redshifts up to the limit of the spacecraft, so 20, maybe up to 22 redshift. At that point, the light's very redshifted. In any case, very high redshifted galaxies. But I'm able to predict what their angular diameter should be. The median angular diameter should be 0.2 arc seconds. And that's about 10 times smaller than what the Big Bang would predict. So there you go. Here's another prediction that we don't have data one way or the other yet. We've only got the data out to the redshifts of about 16 or 18, something like that. But I'm predicting that as we go even further out to redshift of 2022, the median diameter of these galaxies that are yet to be detected in the James Webb Space Telescope, they should be around 0.2 arc seconds in diameter, whereas the Big Bang would have them being around 2 arc seconds in diameter, a factor of 10 difference. So that's a huge difference that ought to be very easily measurable.
Wow, that's amazing. So I'd like to put up a picture here. This is a picture from a recent debate on the Big Bang Theory. And I'm curious as to your thoughts on those who are claiming that the data actually supports or was expected based on the naturalistic model. And there's several points here in terms of the farthest galaxies. And I'm curious if you're familiar with these points here and what would be a good response. Like we can start with one. One is supposedly have the highest redshift. And they're basically arguing that this is what the Big Bang model would expect, Dr. Lisle.
Well, yeah, any model in which the Hubble law applies, the farthest galaxies would have the highest redshifts. So that's an example of confirmation bias. That's a fallacy where you say my model predicts X, I see X, therefore my model's right, and you fail to account for the fact that every other model also predicts X. So any model in which the universe is expanding, not necessarily the fabric of space, but the galaxies are moving away from each other, according to the Hubble law, the farthest galaxies would have the highest redshift. So yeah, they do, but that fits the Doppler model perfectly well. A second point, they have very low metallicity. Yeah, but remember, the Big Bang predicted their metallicity ought to be 0. And there are some of these galaxies at incredible redshifts that have metallicity comparable to nearby galaxies. There was a study done, something like finding green peas in James Webb Space Telescope data, where it showed that they measured the metallicity of these distant galaxies and found that they have the same range of metallicity as nearby galaxies. That's not what the Big Bang predicted. That's what I would predict. 3, they're time dilated. I don't know if that's been tested, but I would expect that because both the Doppler model and the Big Bang would predict that they're time dilated. The mechanism would be slightly different, but in the Doppler model, it's just a relativistic time dilation due to velocity. In the Big Bang model, it would be an apparent time dilation due to stretching of space. And so the subsequent peaks of light get delayed by the same factor. They predict exactly the same time dilation. I will point out that time dilation argues against the tired light model. So, but it's those first three, second one's not really, well, it's not exactly true, but those first three are perfectly compatible with the Doppler model, as is number 4. Yeah, I mean, you tend to find stars and galaxies in general inside ionized bubbles. That can happen. 5, extremely small, massive, and bright. That is contrary to the prediction of the Big Bang. The Big Bang predicted that these galaxies should be low mass, and that they should end at a redshift of 14. So that is not a prediction of the Big Bang. That was my prediction, is that they would be massive, and they're not small. The reason that secularists think that they're small physically, that they're 1,000 times denser than nearby galaxies, is because they're assuming the expansion of space, which creates this magnification effect, which we don't see. And so the assumption is, well, they actually are magnified. They're just really tiny. But that doesn't make sense, because we already know they're as massive as nearby galaxies and as bright as nearby galaxies. That's what I predicted. That's the opposite of what the Big Bang predicted. 6, oddly shaped. Actually, no, we're finding disk galaxies out there. The oddly shaped, clumpy, irregular galaxies was what the Big Bang predicted, but that's not what we found. We found fully formed, massive galaxies, many of which are spiral galaxies, even evidence of barred spiral galaxies. And then 7, very high star production. Well, again, that's an assumption. The fact is, we find lots of stars in these galaxies because, and then the secularists would say, well, they must be producing stars at just tremendous rates. Well, that's because you've assumed that they've just sort of formed, and at a much earlier time than you previously assumed. And so you have to assume that star formation is much more rapid. I don't need to invoke that rescuing device, because I was expecting these galaxies to already have lots of stars because they're massive. So some of those are not predictions of the Big Bang, and the ones that are things I would predict too.
Wow. You're an encyclopedia worth of information, Dr. Lisle. Sorry, critics. But you just handled all of those. Wow, that's awesome. Sam, any thoughts, brother?
No, I'm not on that. Yeah.
It's a technical topic, Dr. Lisle, and you're breaking it down for us. Really good. I mean, this is excellent. So, okay, I appreciate you. Sam, go ahead.
Yeah, maybe before we move on, is there any observable data that the Big Bang just can't, aside from what we've already discussed, that can't account for?
Well, I mean, there are a lot of things that the Big Bang, there are problems. You'll read problems with the Big Bang that you'll find in secular textbooks, and then there are rescuing devices to explain those. We can talk about some of those. We can talk about the baryon asymmetry problem, which is the fact that the universe is essentially matter only, whereas if the universe formed from pure, the idea with the Big Bang is that the universe started in a very hot, dense state where it was too hot to have matter, and so you just have energy in various forms. And then as the universe cools, it forms matter from the energy. But whenever, which we can do in a laboratory, we can take energy and make matter from it. But every time we do that, we get an equal amount of antimatter. Antimatter is like matter, but the charges of the particles are reversed. So instead of a positively charged nucleus, it's negatively charged antiprotons surrounded by positively charged positrons, anti-electrons, basically. And if the universe formed that way, there ought to be an equal amount of matter and antimatter. That's the baryon asymmetry problem. And there are secular rescuing devices for that. The current idea is that, oh yeah, every one time in 100 billion, you just get matter instead of antimatter. Well, of course, we've never observed that. The earlier models of that predicted the proton decay, which has now been disproved. Protons don't decay within the time span that was allowed by that hypothesis. So that's the baryon asymmetry problem. That's one example of something that the Big Bang doesn't readily explain, why the universe is essentially matter only trace amounts of antimatter anywhere in the universe that are locally produced and almost immediately destroyed when they contact matter. Or the flatness problem, why does the universe have just the right balance of mass and expansion? Well, that would make sense if it's thousands of years old and it's designed by God. But if it just came about by some kind of accident, that's really extraordinary. That's why inflation was invented. That's one of the reasons inflation was invented, to try and flatten out the universe. As you pointed out earlier, the Big Bang has changed quite a bit from its initial the initial version that was invented back in 1931. You have all these extra band-aids that have been placed to fix the various problems with it. So yeah, I mean, there's lots of stuff like that. And I've got a list on my website of problems with the Big Bang if people want to learn about those. So it's just the latest one is really devastating because the data fit the Doppler model so perfectly, and they don't fit the Big Bang model at all. That's what makes the latest discovery just devastating. Is not only does it argue against the Big Bang, but it argues for an alternative. So that's what makes it especially neat, and it makes testable predictions.
Amen. So have you seen any prominent old Earth creationist or even theistic evolutionist scientists engage or interact with your confirmed predictions based on the James Webb Space Telescope?
The silence has been deafening. I have heard almost nothing, which is interesting because you'd think that they would at least say something. The few that have said anything have said, well, this just challenges our galaxy evolution models. Yeah, that's what I predicted you'd say. So, yeah, I get that. They formed a lot earlier, a lot more star formation than you were expecting. Okay. The latest data, though, are more of testing the idea of the Friedmann-Lemaitre-Robertson-Walker metric, the idea that space is expanding. And you can try to patch that by saying galaxy evolution happens in this extraordinary way to leave no evidence of this expansion. But I think that's really pushing Occam's razor to the breaking point.
I love the fact that you not only predicted based on a young Earth creationist starting point what the data would suggest, but then also what the rescue device or the responses would be from the critics and the skeptics. And that also came true. So from a biblical worldview, you can predict or guess how they would respond, those that reject a biblical worldview.
Yeah, the Bible tells us about the universe. It tells us about people. So you can predict both. You can predict both. So
what would be, I'll pick a couple of these out of the hundreds of comments coming in. So here's a skeptic response. And so I'm curious what would be a good way to address it. Andrew Cummings says the galaxies are redshift 14 and not fully mature galaxies. They are incredibly small, forming stars at much higher rates, and have very low metallicities. Actually, I remember you addressed this in the slide.
The assumption is that they're very small because you're assuming this magnification effect that's due to the Friedmann-Lemaitre-Robertson-Walker metric. But I'm suggesting if you eliminate that metric, if you say that metric is wrong, they're exactly the same size as nearby galaxies. And we already know they're the same mass as nearby galaxies. We already know that because that's estimated from their brightness. So they are mature in the sense that they have lots and lots of stars. They're massive and apparently the same size once you eject the FLRW metric. So, and regarding their metallicities, again, check out the study of green peas in James Webb Space Telescope data, which found that these distant galaxies span the same range of metallicities as nearby galaxies. And I'm not saying they're exactly the same. Galaxies come in ranges. Some galaxies have low metallicity, some have high. And what we're seeing is that these distant galaxies have about the same range as nearby galaxies. So check out that study. It's one of the references in my technical paper, which is at the Answers Research Journal.
Okay, very good. I appreciate how comprehensive you are, Dr. Lisle. Sam, would you like to bring us into our next major topic for this evening?
Yeah, something you said kind of had me thinking about the Kalam, and I wanted to ask you a couple questions about that. Everything that begins to exist has a cause, and the universe began to exist. So one objection is that through quantum physics, we've seen nothing or something come from nothing. And so I'm wondering if you could speak to that. Is the nothing, or the equivocating on that word? Is the nothing in a vacuum the same as an absolute nothing? And then what about the mind of the scientist as a cause?
Yeah, you nailed it. There's an equivocation on the word nothing. Yeah. When I say nothing, I mean nothing. I mean what rocks dream of. Right? Nothing. Whereas space or vacuum is something. And I know it's something because it has properties. You can measure it. It has dimensionality. Space is three-dimensional, right? It has length and width and height. And space has certain properties. It has an electromagnetic permeability and permittivity and so on. Empty space has properties. And empty space, one of the things it can apparently do is produce virtual particles. So when we talk about virtual particles, it would be better to say they come from the vacuum. Vacuum being the substance space, the fabric of space, as it were. So virtual particles can apparently pop into existence and cease to exist. And this is kind of theoretical, but at least the math works. It's consistent with the Heisenberg uncertainty principle, and apparently is how forces are mediated. So there are virtual photons that can be emitted by particles and absorbed by other particles, which basically give them instructions to come a bit closer or move away a bit, and that's how electromagnetic forces respond. But yeah, currently I have no reason to doubt that there really are what we call virtual particles that can be brought into existence from the vacuum, and then they go back into the vacuum within a certain amount of time, depending on their energy, and all according to the Heisenberg uncertainty principle. So we got to be careful what we mean when we say nothing. Vacuum is not nothing. Vacuum is something, and it has the ability to produce particles under certain circumstances.
And what about the cause? Is the experiment there done in a way to eliminate the necessity of a cause being the mind that we would say would be the mind of God, but in the experiment it would be the mind of the scientist?
Yeah, it doesn't eliminate causality. I mean, if causality were eliminated, you couldn't study quantum mechanics anyway. We're assuming that cause and effect still apply. It's just how we're able to draw conclusions about what happens. But in terms of the exact details of what's causing the vacuum to produce these particles, I think it's not known. We can put limits on it. We can write equations that describe it, like the Heisenberg uncertainty principle. But regarding what's causing it, the vacuum's causing it. What's ultimately causing the vacuum? Ultimately, God, right? God is the distal cause of everything. Things exist because God so wills it. But in terms of the immediate or proximate cause, the vacuum causes virtual particles, or the laws of nature, if you will, which are descriptions of the way God normally upholds his creation.
And are these experiments or what is being caused, are these things immune to certain laws of nature? Those, or we would say fundamental laws, right? You would have gravity, electromagnetism, strong and weak nuclear forces. So would you agree that there would be 4 fundamental forces? The critics would say that.
Yeah, I think that's true. I think there's good evidence for that there are 4 fundamental forces, and they can be unified under certain conditions. There seems to be good science there. The math is consistent. Nothing's immune from the laws of nature other than God himself. God can suspend laws of nature. He's not bound by them. But when he does that, and God apparently occasionally does that, but it's for an extraordinary reason, and it's temporary. So God normally upholds things in a consistent fashion, which is why we have laws of nature. Laws of nature come from a Christian worldview, really. They make sense of it. The fact that there are patterns to be discovered in nature because God has imposed patterns. He's imposed orderliness on nature and upholds things in a consistent fashion that we can study. So quantum mechanics is not immune to laws of nature. It's counterintuitive because there are things some people think of as laws of nature that is really not. And when you get down to the quantum level, the rules change a little bit. It's not that they change. It's just that we don't see them on the large scale because the gradations are so small. But there's certain things that kick in at the quantum level, like only certain angular momentums are allowed. So you have certain spin states that are allowed. Whereas on the macroscopic scale, you think, well, I can spin a ball at any rate I want to. It doesn't work on the particle level. But that's just because the very small quantum effects, once you get to a large scale, they tend to sort of cancel each other out. We don't see them. We don't observe them readily. But they're not immune. Quantum is not immune to laws of nature. It obeys the same laws of nature as everything else.
So from there, and you brought up unity. So there's unity and diversity. You've got these 4 fundamental forces that are unified by something. And so from that, we would say that thing which is absolute, whatever is providing for this unity, would be something greater that these forces are bound by. And so what would you say maybe to a critic, and this is a more philosophical question, that which is absolute has to be a mind, a personal absolute, as opposed to an impersonal absolute?
Well, yeah, the laws of nature are mathematical, and math is the study of numbers, and numbers are concepts of quantity. Where does math occur? In the mind. That's where math occurs. Math is the conceptual study of numbers. Numbers are themselves conceptual, and the universe obeys math. So if you're an atheist, you got a problem. You got a problem because you got a universe that obeys something that exists in a mind. And you say, well, we got lots of human minds. Okay, but in your view, there was a time when there weren't any human minds. Did the universe still obey math? Now, every one of them to a T would say, well, of course, right? We think the universe still obeyed math before there were minds. But wait a minute, math can't exist apart from a mind, because math is mental, it's conceptual. And frankly, the fact that the universe obeys math is perplexing from a secular point of view. Eugene Wigner, who was a brilliant Nobel Prize-winning physicist, wrote an article back in, I think it was the 70s, which from his secular, apparently he wasn't a Christian, but he was analyzing this question as, why does the universe obey math? And so he wrote this article called The Unreasonable Effectiveness of Mathematics in the Natural Sciences, where he explores this idea of, why does the universe obey math? And his answer was, he didn't have an answer. He couldn't solve that problem. He came to the conclusion that it's a wonderful gift which we neither understand nor deserve. And I'm thinking, well, first of all, and I assume he's speaking somewhat figuratively, but I have to push back on gift. Yes, it is a gift because there's a gift giver, and I can understand it. I can make sense of it because the mind of God is what's controlling the universe. So I would say the existence of science, the fact that the universe obeys laws of nature at all, let alone laws that are mathematical in nature, is consistent with the Christian conception of God. And it's not just any God. It has to be a God who has revealed himself so we can know some of his thoughts. It's a God where we're made in his image, so we have a limited capacity to think in a way that's consistent with him. So when I think about numbers, I'm thinking in a way that's consistent with God. When I think 2 + 2 = 4, that's true because it's something that God's mind has determined is true. And I can explain why the universe obeys these laws because it's the mind of God that upholds all of nature. So I would argue in the Christian worldview, and only in the Christian worldview, can we make sense of laws of physics at all, let alone why they are mathematical in nature.
Yeah, so it couldn't be just some brute fact of the world, some random physical something.
Yeah, that wouldn't make sense of why there are laws, why the universe obeys them, why they're mathematical in nature. Math exists in a mind. How can you have math without a mind? None of that would make sense if there were brute facts, which I would say require a mind anyway. So that doesn't even make sense.
Yeah, and I guess the last question there regarding these laws of nature. This is something that's been discussed by a lot of secular philosophers of science. Even Anthony Flew, for example, he thought that argument itself was something that was that brought him closer to some form of deism. So I guess the question here would be, even Stephen Hawking said that as long as there is a law like gravity, which I think is problematic, that the universe can create itself from nothing. So when we're referring to these laws, we're talking about real forces here. Would you agree that the secular community would say that we're talking about real forces, not just random occurrences throughout a time index?
Yeah, I mean, even secular scientists assume orderliness in nature. They assume that there are patterns to be discovered. What they can't account for is why there ought to be patterns in a chance universe. They all know it's true. And see, I can not only account for patterns in the universe, I can account for their ability to know that there are patterns in the universe because they know God in their heart of hearts. And I can even account for why they deny that God, because the Bible talks about that too. It talks about people suppressing the truth and unrighteousness. That's our nature. And unless God had opened up my eyes, I'd be in the same boat. So I just think it's amazing that the Bible can account for all of these things, even the resistance of the unbeliever. That all makes sense in the Christian worldview, but none of that makes sense in an atheistic worldview.
Amazing. Those are excellent answers. I appreciate that. So what I'd like to do is ask you now, because I've got just an ample amount of questions relating to the distant starlight challenge, all asked in slightly different ways. And so why don't we just engage that in general, Dr. Lisle? What do you believe is the best solution to the so-called distant starlight problem?
Yeah, I think it's what I've called the ASK model, anisotropic synchrony convention model, which basically goes back to the fact that the speed of light in any one direction is not measurable without first assuming it, either directly or indirectly, tacitly. That's something that Albert Einstein wrote about. He knew about that. It's called the conventionality thesis. There's even a decent Wikipedia article on it, believe it or not. It's actually pretty accurate. That's not always the case, but in that case it is. And basically the speed of light from A to B, you can't measure. You can only measure the speed of light from A to B and back and take the average speed. And most people say, well, why wouldn't it be the same speed out as in? Because that leads to inconsistencies. If it's the same speed out, and in relative to one observer, it won't be relative to another observer. And so what Einstein did was he said, I'm just going to stipulate the speed of light in one direction, and that'll tell me what now means at a distance. And so I can use that to synchronize my clocks. And then because it leads to inconsistencies, he said other observers will have different definitions of now, different definitions of simultaneity. And so that's something that you would learn in a freshman level class on Einstein, on the physics of relativity, what we call relativity, is that different observers that are in motion relative to each other have different surfaces of simultaneity. But one of the things you can do is you can define the inward speed of light to be instantaneous, to be infinity, basically, as long as the outward speed is half c, where c is the round trip speed of light. And because the average has to be c. The bottom line is, if you use that convention, and I'm not saying that's the only convention, but I am saying it's the one the Bible probably uses. In that convention, it takes light no time at all to get from the distant stars to Earth using that time stamping procedure. And that's the one that all ancient cultures used. It wasn't until relatively modern times that Einstein basically said, let's let the speed of light be this, out at sea and in at sea. And that means we're seeing not the present, but we're seeing the past. And how far out you look is how far back in time you're looking. I'm not saying that's wrong, by the way. I'm just saying that it's also not wrong to say, no, we're seeing the universe in real time. The light travels here immediately using this visual synchrony convention that I believe the Bible uses. And there's good evidence that the Bible does use this ancient convention. In Genesis 1, when God makes the lights and the firmament, the sun, the moon, the stars also, he makes them to give light on the earth. That's one of their purposes, is to give light on the earth. And the Bible says, and it was so, which implies that they immediately began giving light on the earth. Immediately, as soon as they were created on day 4, they fulfilled their God-ordained purpose, or at least within 24 hours, to give light upon the earth. And so that suggests the visual synchrony convention. And it bothers people that they think, well, the speed of light in one direction, it's either this or that. But it turns out the physics of Einstein does not allow for it to be either this or that. It has to be both and. It's whatever you stipulate it to be. And therefore, there is no distant starlight problem if the Bible's using a visual synchrony convention. It means we're seeing the universe in real time, even today. Not that the alternative is wrong. It's just not what the Bible's using. So that's my elevator speech on the
I like that.
Hope that's somewhat comprehensible.
No, it's great. And I think it's a good way to relate it to that. If you're stuck in an elevator for a couple minutes with someone and they want to know, how do we answer the distant starlight challenge? What's a good way to respond? So if I'm understanding you correctly, basically we're seeing the universe, everything in the universe, even the most distant stars and galaxies, in real time using this visual synchrony convention.
Yep.
Because light's arriving instantaneously, which is consistent with the physics of Einstein.
It absolutely is. That's what surprises people. But Einstein wrote about that. He knew about that.
I've got your book behind me, The Physics of Einstein, which I recommend people check out. Extremely interesting book. Sam, you had a follow-up, brother?
Yeah, there was a paper a while back, and I'm sure you're familiar with it, where a supernova was observed, and the light traveling towards us from the supernova hit a planetesimal, and it traveled around one side faster than the other side. And so from this paper, it was suggested that this shows that we can know that the one-way speed of light is I guess this is constant. This is the same as the half of the two-way speed of light. You familiar with that?
Yeah, I am. I'm familiar with that. Yeah. So I don't think if memory serves, I don't think the author suggested that proves the one-way speed of light, but rather secularists jumped on that and said it proves the one-way speed of light. So what happened is that so there's a supernova, exploding star, really far away, and it gets very, very bright for a period of a month or two, and the light passed by. It didn't hit a planetesimal, but rather it passed by a galaxy cluster, of galaxies, and the gravity from all those galaxies bent the light, and it bent. And so some of the light went above the galaxy cluster, some of it went around to the side and bent, and then some of it went to the other side and bent, and some of it went below and got bent up. And so what we received on Earth was light coming from 4 different directions, and so we saw 4 different images of this one supernova that had traveled different directions around the galaxy. It was amazing. It's neat to see. And then about a year later, a 5th image appeared. There was light that took a longer journey and got bent around in this direction. And so we saw a fifth image of that same supernova. And people have said, see, that means the speed of light's non-instantaneous. Well, I never denied that the speed of light is non-instantaneous unless it's moving directly toward you. It's only in the anisotropic synchrony convention, only light that is moving directly toward you is instantaneous. There is an equation. I've written down the equation. It's c over 1 minus the cosine of theta, where theta is the direction away from directly toward you. And that tells you what the speed of light is in different directions. Remember, it's half c when it's moving away from you. It's c when it's perpendicular, and it's infinity when it's toward you. But if you think of the different legs of that journey, the light first has to go up a little bit to then get bent around the galaxy to then move directly toward Earth. So when it's moving in this direction, it's not moving directly toward Earth. It has to get bent to that direction. And so its speed will be slower. And so the anisotropic synchrony convention predicts that the fifth supernova image, because the light deviates more from a straight line, it will be traveling slower in this direction until it gets bent directly toward us, and then it speeds up to essentially infinity. So we would also predict that the fifth image would appear a year later. And that has to be the case because the Einstein synchrony convention, the stipulation that the speed of light is the same in all directions, and the anisotropic synchrony convention, which stipulates its infinity toward you and 1/2 c away, they're coordinate systems. And therefore, they have to predict the exact same observable phenomena. They'll differ on what coordinates we assign to it. But if two asteroids are predicted to collide under the Einstein synchrony convention, they'll be predicted to collide under the anisotropic synchrony convention. They predict the exact same observable phenomena. And that was proved by John Winnie back in 1970, I think, maybe 60s.
Is this the misconception or argument that Dr. Hugh Ross used in your most recent discussion? Okay.
And he had the same misconception. He was thinking that ask means the speed of light, the one-way speed of light's the same no matter what the direction. No, it's only when it's moving directly toward the observer. And so for the first leg of the trip, the speed of light would have been slower. It wouldn't have been instantaneous because the light is traveling not directly toward Earth. It has to go up above the galaxy or below or to the left or the right. So yeah, Hugh Ross had made that same assumption.
So if this is what, you did a great job. So if Hugh Ross in your debate utilized that, if he thought that would be a good challenge directly in your discussion to use against your model on distant starlight, is this really the best they got then? Because it seems like you're easily addressing it.
Yeah, I don't think there's a good challenge to this, and I have to back up a little bit. The anisotropic synchrony convention is a convention. It will never be refuted because it's a coordinate system. It's like trying to refute the metric system. You can't do that. It's a way of assigning numbers to something. And so that'll never be refuted. People have tried. I had a guy try recently and I responded. Phil Dennis tried to refute the conventionality thesis. And I responded on the website showing that he had made some false assumptions. His was kind of mathematical, but it's still the same. It's still the same fallacious reasoning. Now, I have made the claim, and this is falsifiable, that the Bible is using that coordinate system. That could be true or it could be false, right? That's not a convention. That's a factual claim. I think it's true. That could be refuted. I don't think it will be. I think there's good evidence that the Bible uses the ancient method of defining when something happens by when we see the light arrive. Every ancient culture did that. It wasn't until modern times we began subtracting off a hypothetical light travel time by stipulating its one-way speed to be c. So yeah, so I don't think anybody will ever refute the conventionality thesis or the ask coordinate system, but the model is theoretically falsifiable. It just hasn't been falsified yet because I think it's a good model.
Yeah. And I appreciate that you've engaged the critics in video form, in written form, and also in several interviews that you've done. And so here's a skeptic who's been wanting to challenge your model here. And so he sent this in advance. And I think, or wait, not that one. Let me see. I think you kind of just addressed it actually, but let's leave no stone unturned. So right here, Mr. Anderson. And so he says this, it's a two-parter. We'll work through it. He says, you say that it is impossible to measure the one-way speed of light, but also that you believe it is infinite coming toward us, which means we see the stars as they are. And part two of his question here. The speed of light coming towards us is instantaneous. We can see distant starlight to synchronize clocks and accurately measure the one-way speed of light. Which is it? Immeasurable or not?
Yeah, it's not measurable without first assuming it. You can presuppose it, because it's not a question of nature. It's a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. So if I stipulate the speed of light to be instantaneous toward me, I can use that to synchronize my clocks. And then when I measure the speed of light using my synchronized clocks, I'll find it's exactly what I stipulated it to be. And so, but you can do that with you can do that with any synchrony convention. You can say, I want the speed of light to be 3/4 C this way, and whatever it is in the remaining trip, and synchronize your clocks that way, and then measure it. But you see how that's circular? You can't independently measure the one-way speed of light without first assuming it, and that's because it's not, as Einstein put it, the speed of light in one direction, he said, is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. That's in his 1916 book on relativity, so you might check that out.
That's good. That's really good. And so right here just came in, based on what we were talking about earlier, you recommended a paper, green Pea Galaxies, I think it was, a specific point. And so this viewer said that he went and looked it over a little bit. And so he's got a follow-up question.
Okay.
And he's asking, why did Dr. Lisle imply that these green Pea Galaxies were more distant redshifts of Z14 with high metallicities? There we go. Metallicities when they're really Z8.
Oh, okay. I didn't mean to. If you got that impression, I apologize. But they are part of the James Webb Space Telescope data, and you need to understand that in terms of distance, Z versus 8 versus Z versus 14, it's not tremendously different in terms of distance or time. It gets more compressed as you get closer to higher and higher Z. So my point was simply that we have very high redshifted galaxies that, according to the Big Bang view, are extremely early in the universe. And yet they have metallicities that are comparable to nearby galaxies. So those galaxies, if memory serves, they're within the first billion years of the universe. And they're comparable to 10 billion year old galaxies in terms of their metallicity. That's the point I was trying to make. So I apologize if I miscommunicated.
No, you did a good job. I appreciate that. Okay, on the distant starlight argument, even myself pretending to be a critic, I can't think of really any real challenge or refutation that you haven't addressed or engaged. And so, and we've addressed a lot of what the critics are saying here. So let's just move and shift into our last topic as we move towards the 2-hour mark. Dr. Lisle, again, I appreciate how comprehensive you are. Thank you for your time, and just been a really great program tonight. Time has flown by. And so, okay, we've discussed C14 in diamonds earlier and how that contradicts an old Earth. Carbon dating is a form of dating method for an old Earth, but let's discuss a little bit your other dating methods and how your critics, they'll look to older rocks and they'll say that these date older than your younger rocks, and so the geological strata must be billions of years old rather than just a few thousand. And so, Dr. Lisle, I was wondering, what's a good general response, maybe an elevator response to those kinds of dating methods?
So, well, yeah, with there is some question as to can we use radiometric dating at least to give relative ages? If something has a radiometric estimated age that's older than this rock, does that mean it's genuine, even though it's not millions of years older? Is it older than that rock? And I think a lot of creationists are open to that. It's not something that, I'm not a geophysicist. It's not something I've specialized in, but there might be validity to that. One way there would be validity to that is if the radioactive decay rates were accelerated during, for example, the time when these rock layers were being laid down. So let's say they're flood layers. Now you can't, flood layers would be sedimentary rocks, but sometimes you'll have an igneous rock that's within those flood layers, and you can use the radiometric age dating methods on that igneous rock. Radiometric age dating methods are only really applied to igneous rocks, not sedimentary. And so the idea is rocks that are lower in the geologic column, which we would say are earlier in the flood year, have more daughter elements in the radioactive decay process. We would expect that if accelerated decay happened during the flood year. And apparently there is some evidence that that's the case. So can we use radiometric dating at least to get relative ages? Possibly, but it doesn't give you the absolute age, because the absolute age presupposes that the radioactive decay rates have been constant throughout history. That's a uniformitarian assumption, and there's good evidence that it's wrong. The rate research group found very compelling evidence. I was not expecting it, that the rate of radioactive decay was faster in the past, possibly during the flood year, possibly during creation, possibly both. And we know it's possible. There are certain types of radioactive decay we can speed up in a laboratory by a factor of 1 billion. The rhenium osmium reaction can be sped up in a laboratory by a factor of 1 billion just by stripping the electrons away, and you get bound state beta decay. So we know that's possible. It doesn't require even a miracle. And of course, God's open to doing things in ways we can't do. So that's the thing you have to watch out for. What are the assumptions that are involved in these dating methods? And inevitably, some degree of naturalism and uniformitarianism. And those are assumptions that I, as a biblical creationist, would reject.
If I could follow up with that, what are because you mentioned accelerated nuclear decay, and then the lines of evidence that the rate team discovered with their observations. The three that I typically hear and will convey when people ask me about it are radio halos, helium and zircon crystals, and also fission tracks. Mm-hmm. I find the radio halos one sometimes difficult to convey.
Me too.
but but the helium one, I feel like is a little easier to understand, I guess, and makes a lot of sense too. And so I'm wondering and I think I know now, what your favorite lines of evidence are for accelerated decay.
Yeah, the helium one I find really compelling and fairly easy to explain, because when radioactive decay happens, when a uranium atom, and it turns into another atom, which turns into another, all the way down to lead 206, lead stable. So once you get lead, the process stops. But if you have a bit of uranium in a crystal, in a rock, during that process, every atom of uranium that changes into lead produces 8 helium nuclei as part of that process. And helium, that helium's a gas. It'll easily grab onto a couple of electrons and become helium gas. And helium is a gas, and because it's a gas, it can move through rocks. Rocks are porous. We think of rocks as solid, but they have little gaps in them, and gas can escape through rocks. And so what we find are rocks that have evidence that they once had uranium in them. They probably still have a little bit of uranium in them, and lead, and there's helium as a byproduct. So that tells you, and there's a lot of helium. And so that tells you a lot of uranium has decayed into lead. A lot of that's happened. And you say, well, there you go. See, a lot of decay has happened. That takes millions of years at today's rates. But here's the problem. If that happened at today's rates, the helium would have had plenty of time to leak through the rock. It doesn't take long. We've measured the rate at which helium can move through rock, and it's temperature dependent. But we can map that out and take a look at what the temperatures would have to be and so on. And we find that in over millions of years, the helium would be gone. It would have all leaked up into the atmosphere. And so the fact that we still find helium tells us that a lot of decay has happened, and it happened recently, not millions of years ago, or otherwise the helium would be gone. And so the logical conclusion to that is the decay rate must have been faster in the past. And again, this is a line of evidence that I find very compelling. It's consistent with the polonium radio halos. It's consistent with the fission tracks. I just find it easier to understand than those two. But fission tracks are produced when you have like uranium in a crystal, and it'll damage when it releases some of these particles. It'll damage the crystal, and so you'll see these little lines zipping away. Those are fission tracks, and the problem is fission tracks over millions of years, they should disappear because they get randomized. Thermal motions in them tend to eliminate the fission tracks, but there they are. And so again, that's an indication that you have a lot of radioactive decay happening, but happening relatively recently, and therefore at a much accelerated rate.
So if I understand the helium one correctly, basically we know that a lot of decay has happened and had to happen in a short amount of time rather than over billions of years, because helium, being such a slippery molecule, should have all leaked out if we're looking at uniformitarian or actualist rates, where it's taking billions of years. So the fact that it's still there, but yet a lot of decay has happened, tells us that decay must have happened over a short amount of time.
That's it.
Okay. Well, yeah, that is that's an excellent line of evidence for accelerated decay. So I'm curious, Dr. Law, have you seen any good responses or counters at all from the critics to that?
Not really, not really. I mean, you can always nitpick this stuff. You can always say, well, the rate could be different in the crystal than it is in the rock, and so on. I get that, but it can't be millions of times different. So I think this is a very compelling line of evidence. I have heard some criticisms. It is temperature dependent, so they'd say, well, the temperature could have been really low. The lower the temperature, the slower the helium leaks. So the temperature could have been really low. Well, it turns out it has to be near absolute zero for you to stretch it out to millions of years. So that's not going to be a good rescuing device either. So the bottom line is I haven't heard a very good rescuing device for this. There are still some T's to be crossed and some I's to be dotted, but the time scale between the two is the predictions are so enormous from the amount of helium you'd expect if it's millions of years old versus if it's thousands of years old, that the data just very strongly are consistent with the biblical model.
So we have the evidence there, I think, very clearly for accelerated decay in the past. Now, the big follow-up would be from the critic and the skeptic of young Earth creation. They'll say, okay, let's assume you're right. Accelerated decay has happened. That much decay in such a short amount of time, especially during the flood year, would result in so much radiation and heat as a byproduct of this accelerated decay that it would basically evaporate the oceans, melt the crust, kill Noah, his family, the animals. And so there must be a different explanation for the helium, the radio halos, and the fission tracks, because accelerated decay just doesn't work because of that after effect. And so, Dr. Lisle, I'm curious, in your opinion, what's the best way to engage and interact with that objection?
If somebody says, well, there's a different explanation, cool, go for it. Accelerated decay is not something the Bible mentions. I'm open to other possibilities. Okay. So it's just that one I think is the best. Then with regard to the two objections, and they're two separate objections, because I think one's easy to answer, that the level of radioactivity would have killed all life on Earth, killed Noah and his family. No, it just wouldn't, because they're sitting on top of a mile of water. And water is really good at absorbing radioactive elements. The radioactivity is not going to go all the way from these heavy elements that are deep in the earth, all the way up through a mile of water up to Noah. If you smooth out the Earth's surface, the Earth would be covered with water to a depth of 1.6 miles. So they're not going to have to worry about radioactivity. The only element that causes possible concern, there is one of the lighter elements that comes in a radioactive form. It might be calcium, and there's some. People say, what about C14? We don't think it was accelerated very much. We think the rate of acceleration is proportional to the half-life of the element. So C14 is already a fast decayer, and there's only one atom in a trillion, and there would have been less at the time of Noah's flood, only 5% present values. So C14 is not a problem. There's one lighter element, maybe calcium, and we don't know how much of radioactive version of that element was in the environment. There might not have been any at the time of the flood. But the heavier elements that are in the earth that would have been producing this radioactivity, it's going to be blocked by 1.5 miles of water. So that's not a problem at all. Now, the heat problem is more interesting because radioactive decay produces heat. It releases energy. And when that energy thermalizes, it causes the atoms to vibrate faster. It increases the temperature of whatever's around it. So, and that's something that, a lot of thermal energy was created during the flood year, if indeed the radioactive decay happened during the flood year, as I think is the most likely model. So the question is, is that going to boil the oceans? Empirically, it didn't. So, I mean, I think that's probably, I think that's not an issue. But at the same time, you're welcome to ask, how did that energy get dumped? Where did it go? And the answer is, we don't know for sure, but there are different ways to dump energy. One of them is you can dump it to space. Hurricanes take energy from the ocean floor. They take an enormous amount of thermal energy from the ocean, and they move it up into the atmosphere and eventually dump it to space. When hurricanes move over the ocean, the ocean temperature drops by 10 degrees, and water has really high, what's called a specific heat. Water can store an enormous amount of thermal energy. So hurricanes, we think there were probably hypercanes during Noah's flood, because hurricanes today move over land. They get cut off from their power source and they peter out. There would have been no land during the flood year. So hurricanes could build up to hypercanes, and that would be a really efficient way of dumping the heat to space. It's possible that some of the heat went into the Earth. Today, the Earth has a molten core. we don't know that it always had a molten core. That's something that I've been toying with, is did some of the energy go into the Earth? And if we take all the Earth's internal heat, would that account for all the heat that was produced during accelerated decay? So there are different ways to dump the energy to space. So it's not a problem, but it is something that we should investigate, and creationists are continuing to investigate. My point is, it's not a fatal problem. Nobody's come along and said, this is the amount of energy that was produced and you can't get rid of it. There's no way to get rid of it, because we know of several ways to get rid of it. So they'd have to eliminate all those as possibilities. But I think it's an ongoing investigation as to what are the mechanisms and which is the most important.
Sam, before you go, I wanted to make one point, because I really like your hypothesis on the core. I think that's really good. And I think there's a good research project there, really. And so we don't necessarily know the temperature of the core it could have been icicle. I don't know. And so a lot of that energy and heat could have gone to the core. And now the core, we understand, is extremely hot today because of that. So I'm curious, how would that heat be transferred to the core? Would that be like a supernatural transferring by God, or is there something going on scientifically that?
Yeah, well, I mean, first of all, I don't know that that's the right explanation, and it's probably not the full explanation. There's probably multiple processes going on. I'm inclined to, since God normally works by natural phenomena, that's, in fact, I would define natural phenomena as the normal way that God accomplishes his will, as opposed to a supernatural action. I always default to that unless I can find a scriptural reason not to. So I'm inclined to think that these would be natural processes. Hurricanes are natural processes. Water having a very high specific heat and being able to deliver that heat, that's a natural process. But they're basically different ways of getting energy from one place to another. Thermal energy is either transferred it's usually by conduction, direct contact, although that's a very slow process, or radiation, and not the kind of radiation associated with radioactivity, but just thermal emission, electromagnetic waves. And that's fast. And then convection is also very fast. And we do think there was a lot of convection taking place at the time of the flood. Convection is where you're actually moving the object that has the heat with it. So you're moving. We think that the ocean floor was completely replaced at the time of the flood. So a lot of convection going on there. And then there are other ways you can get rid of energy too, magnetically, Alfvén waves, and so on. But those are the three big: conduction, convection, and radiative transport.
Very good. Sam?
Oh, no, I'm good. I was going to make a comment, but you touched on it. So
there we go.
Thank you.
We think alike, brother. We think alike. So, okay. Well, firstly, Dr. Lisle, excellent endurance. We've hit the 2-hour mark, and that's basically been 2 hours of challenges, major topics, technical topics, engaging many of our skeptics and critics in the chat. And I am extremely happy with this. I wanted to leave no stone unturned, touch on the major topics: dating methods, heat problem, distant starlight, some of the biblical points and arguments that we started off with, which I'm glad we did, set the foundation for the show. And so, my brother, Dr. Lisle, I really appreciate your time here. Is there any final words, final thoughts you wanted to leave us in the audience with as we wrap things up?
I hope it's been encouraging to you. I'd encourage people to check us out on the website, biblicalscienceinstitute.com. A lot of great resources. The website itself is a free resource that I'd encourage you to check out. And we have videos too. We got our Rumble page, and a lot of resources too for books and DVDs that you can get on our website. And so check that out. Check out our latest article that I've got posted. It's posted today. We posted a little while ago. It's a summary. It's a layman's summary of this latest research on the James Webb Space Telescope data and what I'm calling the Doppler model. So that's pretty neat. And it references the technical paper too. So check that out on the website, biblicalscienceinstitute.com. And thank you much for having me on the show.
Okay, my pleasure. I appreciate how you do that. You'll release a technical paper, and then you'll put a layperson article with a nice summary for people to read and understand better. So, okay, very good closing thoughts. Here are links to Biblical Science Institute, and you can find in the description box links to where you can read these articles, including Dr. Lisle's most recent technical paper. So, Dr. Lisle, appreciate you doing this. Sam, my award-winning co-host, appreciate you doing this with me, brother. Any final words from you?
Yeah, no, Dr. Lisle, I'm a fan. I've listened to much of your stuff. I've got a few of your books, and haven't gone through all of them. But I want to thank you especially for your book, The Ultimate Proof of Creation, because that took away so much anxiety. It opened my eyes to look at this whole discussion in a different light, and it's really encouraged me in my faith. So I would recommend that to anyone to read. The title is spot on. It's probably not what most people think, though. Fantastic book. And so thank you again for your time. It's really been a pleasure.
Oh, thanks. I appreciate that. That's encouraging.
Amen. Major game changer, life changer for me as well when I got saved years and years ago. So, okay. Well, with that, thanks again, Dr. Lisle and Sam, my brothers, and to the audience. Thank you so much for tuning in. I appreciate all your questions. I apologize if we couldn't get to your specific question, but we had probably about 100 questions. So we got to as many as we could. And I appreciate you guys interacting and supporting today's stream. And so with that, Standing for Truth is out, and God bless all.